If you're trying to make a solution with a tiny amount of solid, well, don't try to just weigh out exactly the amount of solid that you calculate that you need. As long as you don't need an exact volume, there's a much better way. Rather than trying to measure out exact tiny masses, adjust your volume to match the mass that you measure. Long story short, weigh out at least what you need, a little more is fine. Take that measured mass, divide it by your desired concentration, and that will get you the needed volume to reach that desired concentration. Dissolve it in that volume, and voila, you've got the concentration you want without having to fiddle around trying to measure tiny amounts. This is a lot easier than fidgeting around trying to get exactly on the dot, especially because, well, when you go and you close the doors so that the air doesn't interfere with things, then things are going to change. So don't sweat it. Calculate how much mass you need in order to get your desired volume. So in order to get your desired volume, well, now you might have to actually go and figure out how much am I going to need, and then prepare to make a little extra. Speaking of a little extra, you want to weigh out at least the amount that you need, but if you have a little extra, it's fine. Like, you don't want to go wasting stuff, but if you have a little bit over, no worries. Take that out and now calculate how much volume you need to add in order to get to your desired concentration. Sometimes if you have a really small amount, so what I like to do is, instead of using like one of those weigh boats, I use this little weigh paper, fold it in half, get a little taco, weigh it on there, close the doors, get the final amount, take it out and carefully dump it. If you're dealing with a really, really small amount and you want to do it in like an Eppendorf or something, sometimes you can measure it in the container, and that way, be sure you carry your container though, so zero the balance. But you want to weigh it in there so you don't have to worry about the transfers and stuff. Another thing to do is to just avoid having to do these teeny tiny measurements, and so make a higher solution initial solution, a higher concentration initial solution, and then just do a dilution calculation. But if you have a tiny amount of precious stuff that you're not wanting to like worry about wasting, then if you're trying to measure these tiny amounts, change the volume rather than changing the mass. In order to figure out the mass that you need, well, if you're starting with a mgs per mil or something that you want to get as your final concentration, that's great. If not, what you're going to need to do is convert using the molecular weight. So remember, the molecular weight is grams per mole. If we think about molarity, that is going to be moles per liter. Now, mgs per mil is the same as grams per liter, and molecular weight is grams per mole. So what you can do is take that molarity that you want, your desired final molarity, multiply that by the molecular weight. So you take moles per liter times grams per mole. The moles cancel out and we're left with grams per liter. One of the things that you should start to get good at in the lab is realizing that if the prefixes in the top and the bottom are the same, then you can use any two prefixes on the bottom and the top that are the same. Basically, grams per liter is the same as mgs per mil. So now you've got your concentration in mgs per mil or grams per liter. Remember, those are the same thing. To get a mass, just need to multiply that by our desired volume. Now that will then cancel out the units, and you're left with your needed mass. And so if you were in grams per liter and you would need to multiply by liter in order to get the amount of grams, if you're in mgs per mil, you'll still have that same initial number, but now you're going to want to multiply by milliliters, and that's going to give you the number of mgs that you need. So you want to measure out at least that mass, but a little more is okay. Now what you want to do is you need to figure out the volume that matches that mass. So if you were to take your measured mass and divide that by the needed volume, you'd get your desired concentration. We know the desired concentration. We just measured our measured mass. Now we need to figure out our needed volume. So just switch things around in your formula. Voila, your needed volume is going to equal your measured mass divided by your desired concentration. As long as your units are all consistent, what you're left with is your needed volume. So here is a worked out example for that I actually do in the lab. So let's take an example where we want about 20 mils of 10 millimolar NaDH disodium salt, which is a solution I make a lot in the lab because it allows me to study the activity of the enzyme malodehydrogenase that I work with. So I want about 20 mils of it so I can make a bunch of stocks. How am I going to do this? First, I need to convert my desired concentration to mgs per mil equals grams per liter if needed. So do I need to? Yes, because right now I have it in millimolar. If I have it in molarity, so moles per liter, well, then I can just multiply by molecular weight or the formula weight, which is going to be grams per mole. The moles would cancel out, leaving me with grams per liter, which is the same as mg per mil. Currently, I'm in millimolar. And so if you get really good with your conversions, you can just think, oh, millimolar. Okay, there's 1,000 millimoles in a mole. And so what I need to do is I need to move my decimal place 3 places to the left, 1, 2, 3. And that would give me the concentration in molarity. I could also do this more explicitly and write things out. So 1,000 millimole per mole, multiply 1 mole over 1,000 millimole times 10 millimole over liter. Millimoles cancel out, and that's going to leave us with our desired molarity, moles per liter. And in this case, it's 0.01. So again, the shortcut is just move your decimal place 3 left. But if you need to write things out to see it, then that's how you do it. So now you have your molarity, and we can look on the bottle and see the molecular weight is going to tell us it's 709.4 grams per mole. Now, if I multiply the molecular weight by the molarity, the moles cancel out, leaves me with grams per liter. Another one of the little shortcuts you should start to be able to see is that grams per liter is the same as mg per mil. As long as the units, the prefixes on top and bottom are the same, you can make them any sort of top and bottom being the same, and it'll be consistent. Because you can basically multiply both of these by 10 to the minus 3, so divide them by 1,000. This would give this in mgs and this in liters, so 7.094 grams per liter is the same as 7.094 mgs per mil. So now I can figure out how many mgs to weigh out to get to that 20 mils. Alternatively, I could have converted 20 mils to 0.02 liters, again, doing the 1, 2, 3 moves of the decimal place. And then I could have stuck in grams per liter, and that would then give me the amount in grams. Okay, so now I want to calculate the target mass based on this target concentration and the target volume. So my target volume is 20. My target concentration, that's what I just figured out. My desired concentration is what I just figured out. And so now what I want to do is I need to count the target mass by multiplying those two together. So target mass equals desired concentration times target volume. I just plug those in, and I end up getting 141.9 mgs. So now I want to measure out a mass that's close to that. And so maybe I go and I measure out 161 megs. Now what I need to do is calculate the volume needed to reach the desired concentration. Before I go and actually calculate it, I should think for a second. So I know that I measured a little bit more than 141.9, and so I should get a little more than 20 mils. So reasonableness checks. Before you do a calculation, what are your expectations? Then do your work and check if it is actually reasonable. So I expect my volume to be bigger. Let's see if we end up with a bigger volume. If we end up with a volume that's bigger but close to the value, that'd be good because we're pretty close to that calculated value. So we shouldn't be too far off, but we should be above. Now let's go and actually do it. So to calculate that needed volume, I need to divide the measured mass by the desired concentration. If I do this, I end up getting 22.7 mils. That's a little more than 20, so all's good. So the basic strategy is calculate a target mass based on your target volume and desired concentration. You want your desired concentration to be in units of mgs per mil or grams per liter. And if you start with molarity, you can get to that by multiplying that molarity by the molecular weight. Now you know your target concentration, you need to figure out your target volume. So to do this, you might need to go and look at all the reactions you're going to do and how much you think you need. And then you want to calculate to make that. The desired concentration is going to be equal to the target mass divided by the target volume. To get to the target mass, you therefore need to multiply both sides by the target volume. So the target mass is going to equal the desired concentration times the target volume. Measure out a mass that's close to that. It's okay if it's not perfect. If you need at least that much, you need to measure out at least that much. If you don't care that you have at least that much, you just want somewhere around there, then no worries. Now you want to calculate the volume needed to reach the desired concentration. So if we go back to thinking about, okay, well, if our desired concentration is our target mass over our target volume, it's also equal to our measured mass over our needed volume. Needed volume is therefore equal to our measured mass divided by our divided concentration, and voila. Just make sure that your units are consistent so they cancel out appropriately. And at the end of the day, hopefully your solution is good to stay. Couldn't think of a good rhyme. Sorry.